This project is an implementation of a widely used system called automatic number plate recognition. The automatic number plate recognition, also known as ANPR, is a technology that uses optical character recognition on images to read vehicle registration plates to create vehicle location data. It can use existing closed-circuit television, road rule enforcement cameras, or cameras specifically designed for the task. ANPR is used by police forces around the world for law enforcement purposes, including to check if a vehicle is registered or licensed. It's also used for electronic toll collection on pay-per-use roads and as a method of cataloging the movement of traffic, for example, by highways agencies. The ANPR can be used to store the images captured by the cameras as well as the text from the license plate. With some configurable to store a photograph of the driver, systems commonly use infrared lighting to allow the camera to take picture at any time of day and night. ANPR technology must take into account plate variations from place to place. There are three steps involved in number plate recognition. The first step is to detect the license plate from the car. We will use the counter option in OpenCV to detect for rectangular object to find the number plate. The accuracy can be improved if we know the exact size, color, and approximate location of the number plate. Normally, the detection algorithm is trained based on the position of camera and the type of number plate used in that particular area. This gets trickier if the image does not even have a car. In this case, we will use additional step to detect the car and then the license plate. Once we've detected the license plate, we have to crop it out and save it as a new image. Again, this can be done easily using the OpenCV. Finally, the new image that we obtained in the previous step is sure to have some characters such as numbers and alphabets written on it. So we can perform the OCR, the optical character recognition on it to detect that number and store it to the database. Here is a more specific explanation for the first step, the number plate detection. Resizing can help us to avoid any problems with bigger resolution images. Make sure the number plate still remains in the frame after resizing. Grayscaling is very common in all image processing steps. So this speeds up other following processes since we no longer have to deal with the color details when processing an image. The image will be transformed something like this when the step is done. So the second step, for the second step, every image will have useful and useless information. In this case, for us, only the license plate is useful information, and the rest of them are pretty much useless for the project. So this useless information is called noise. Normally, Normally, using blurring will remove the unwanted details from an image. So the third step is interesting, where we perform the edge detection, and there are many ways to do it. The most straightforward way is to use the canning edge method from the OpenCV library. After that, once the contacts have been detected, we sort them from big to small and consider only the first 10 results, ignoring the others. In our image, the counter could be anything that has a closed surface, but of all the obtained results, the license plate number will also be there since it's also a closed surface. After we know where the number plate is, the remaining information is pretty much useless for us. So we can proceed with masking the entire picture except for the place where the number plate is. The next step in the number plate recognition is to segment the license plate out of the image by cropping it and saving it as a new image. We can then use this image to detect the character in it. And the final step of the whole project in this number plate recognition is to actually read the number plate information from the segmented image. In this project, I will use OpenCV, PY Tesseract, and Tesseract for automatic OCR number plates. The OpenCV, its full name is Open Source Computer Vision Library. It's an open source computer vision and machine learning software library. OpenCV was built to provide a common infrastructure for computer vision applications and to accelerate the use of machine awareness in commercial products. As a BSD licensed product, the OpenCV makes it easy for enterprises to exploit and modify code. Optical character recognition or optical character reader, the OCR, is the typing, written, or printed text image converted into machine code in the form of electronic or mechanical text, both in terms of scan files, photos, and pictures, such as landscape photos of logo and the words on the billboard, or image on the subtitle text, such as television and radio. In our first experiment, we're going to use the picture shown in the previous section to test our AMPR program. In this experiment, I used the figure above as the image input. The AMPR program should be able to capture and crop the nameplate and output the correct value of the nameplate. The expected corrected value is CZ20FSE, and as shown in the right figure, our AMPR program successfully cropped and outputted the nameplate by removing the noise. And the figure in the top shows that the output license plate value also matches our exception. In our second experiment, we are going to use another picture with a different license plate from a different country to check our MPR program is applicable for all license plates in all different countries and regions. The second picture is a car with a California license plate. The ANPR should be able to detect and recognize the US license plate since the ANPR application is widely used in the US. As you can see in the bottom picture, the ANPR program successfully cropped and outputted the nameplate by removing the nose, and also the output value of the license plate also matches the expected value. Here are two failed cases we encountered during my experience that I would like to mention. In this case, so the first case, we use a car with a Chinese license plate as the input. The ANPR program successfully cropped the numeric and the alphabet part of the license plate. The output result is BD01113, but the correct value, the value we are expected to get of the license plate should be Jing BD01113. So the Chinese word Jing is not successfully recognized and detected. So this ANPR program does not support words other than numeric and alphabet words. So this ANPR program does not support license plate in some countries. It can only recognize and detect a part of the characters. In the second fail case, the expected value of the license plate should be P3RKELE. I don't know. So the clarity of this picture is very low and even not human readable. So the output of our program is not able to detect and recognize the license plate correctly. So this problem can be fixed by improving the quality of the camera to improve the quality of the pictures taken. According to the result of the experiment 1 and experiment 2, we can find that my ANPR application can successfully recognize the lens plate that combined with the alphabet and numeric characters. Hence, it supports the license plate in most countries. And my examples only shows the license plate in the US, in the California. But if we took a look at license plates in other well-known countries, we can find that they're also combined with only alphabet and numeric characters. Here are some examples of photos of the license plate in different continents around the world. So one is a license plate from Canada, and the other one is from Brazil. Although my ANPR application is applicable for the license plate in most countries and regions, the experiment 3 still shows a fail case that may happen when this application is deployed in some countries where the lens plate combines not only alphabet and the numeric characters. So an example is the lens plate in China. As shown in the left figure, you may find that the format of the lens plate in China is very similar to the example in previous figures. So the only difference is that the Chinese license plate starts with a Chinese word. So those Chinese words indicate the province of the license plate. Knowing this, the problem can be very easily resolved. So when this NPR is deployed in Liaoning province, for example, so we can think that the first Chinese character is Liao as default. So the remaining work is just to recognize the remaining numeric and the alphabet part. So other than the Chinese license plate that can be mostly recognized by our NPR application, there are another type of license plate that completely cannot be processed by the NPR application. So as shown in the right figure, most part of the IRAN lens plate do not have numeric or alphabet characters. To be honest, I don't know how to. I don't even know how to read them at all. So my NPR recognition does not support the license plate in IRAN at all. So this is a failure case that cannot be resolved so far. The last failure case I want to mention is shown in the figure above. So when the input image has a low quality, which means that the photo is very blurry, the NPR program may output incorrect result or cannot find the license plate at all. So this problem cannot be resolved at the application level since most of the picture is not even human readable. So we cannot resolve this problem by optimize our code. So the solution should be at the hardware level. So that is, we need to improve the quality of the input photo by changing a better camera or find a better position for the camera, etc. Automatic number plate recognition, ANPR, is a technology that uses OCR on images to read vehicle license plates and create vehicle location data. So this technology is now widely used in many real-world applications such as transportation systems, and it brings a lot of convenience because can work 7/24, which saves a lot of manpower. This project implemented ANPR using simple OpenCV Python code. This ANPR application consists of three main steps. The first one is license plate detection, which means give a photo of the car, the application will be able to detect the nameplate from the car. The second step is called license plate segmentation. After the license plate is detected, our application can segment it from the entire image. So the purpose of this step is to keep only the useful part of the image for the last step. The character recognition in this step, the application will take the output of the previous step, a picture with only the license plate as the input, and finally output the digital cameras, the digital characters of the license plate in text form. So the future work can be extended based on the failure cases. So the first failure case indicates that if the license plate contains characters other than numeric and alphabet character, then the NPR program will not be able to read and recognize them. So some future work can be done in the software level, in the code level, to optimize the program to make it applicable for more characters. So another failure case is caused by the low quality of the input photo. So the future work can be done in the hardware level to improve the quality of the input photo to improve the AMPR program. Alright, thanks for watching.